Hey, I'm Willie. So today I'm going to demo about my project about design pattern. So it's actually a CLI command line interface program that will show the that will allow you to play mini games and actually understand it in a playful way. So after you have cloned from my repos and install the dependencies, we'll run Python main.py from the root, and then it will show you a menu for 23 design patterns. So here uh, you can choose uh, from any pattern you want, but here we can actually randomize one. So I will randomize here and we get flyweight. Okay, so let's actually play a mini game of it. So flyweight is actually a design pattern that where you have it's where you have like an object that may shares a lot that like you have lots of uh, object that they basically have pretty much the same intrinsic value, so you either just want to just use one object and you make many references to it, so it will decrease the memory use. So here, let's create one human, and in this mini game, let's name him Bill. Okay, so in this mini game, I just want to emphasize about the memory. So let's say each human, uh, they weighs like 50 kilograms. So let's show their weights. So right now, one human is 50 kilograms, and one photo of that human is like zero point 0.5 kilograms. So let's take a photo of existing human, let's say Bill, and then show the total weight, and that will be 50.5 kilograms. So like, let's say instead of creating an object like 100 times or 100 times, and the object itself is pretty heavy, considering they have like many attributes or expensive expensive stuff inside, then it will be large in memory. But if you want to make many objects that share some intrinsic values, then you can just create just one object. So in this case, it's the human Bill, and I can just uh, make many references of the object. Like I can take photo of him like 10 times, and it will be much lighter than just create many times the same human object many times. So let's exit. Let's randomize another mini game. So mediator. So beside mini games, you can go into deep dive mode, which is oh, and I have to tell you that when you enter the deep dive mode, you also have to scroll up because somehow I coded it to return to the main menu right away. But whenever you enter the deep dive mode, please scroll up because it just returns here immediately. But yeah, it's just a reminder. And then and here in the deep dive mode, for each pattern, uh, it will actually explains clearly from the mini game, so you can actually understand uh, deeper for the that design pattern. So enough demo of this. So let's dive into the code itself. So okay, so the main.py here is the file that you will run. As I said, as I did earlier, I run this. So you can see here, I use the rich packages with random to random the choice, and here you can see that lots of importing stuff here, and look at this. This is such a mess, but no one codes this manually, of course. So that's why in this repo we have a script that will actually generate those imports. Like actually it will generate the whole main.py for us. So in this code, you can see here this patterns, this list of patterns. You will in here I entered 23 design patterns, and actually you can delete some or include more, so it will be extensible. So here for the base directory we have patterns, which is this one. So at first it will create a directory of patterns. So base there patterns exists, okay, true. So if it already exists, then it will show that too. So for the game template here, they will I didn't say that for in the patterns folder there will contain 23 design patterns folder as folder, and inside each folder we will have one file for deep dive and one file for game, the mini game. And for the mini game we will actually enforce the method run game, and in the deep dive we will enforce this run deep dive and try to make it consistent across when we call from the main.py. Okay, so in a script, this will be the template for the pattern, the mini game file, and this will be for the deep dive. So we will iterate through. When we enter the patterns names in the list of patterns for this code, we will iterate through each pattern in this list. So for each we will create one folder by joining the base there, so it will be inside these patterns. And let's say it iterates through singleton, then it will go inside here. And the same so for each folder it will have the init.py, so we can easily import it from main.py, as you can see here. So wait, hold up. Okay, and the same for the naming, the game.py, it will iterate through each pattern in the list and actually create the mini game and the deep dive inside the folder for each pattern. Okay, so and after creating it, it will actually write the template as I wrote here. So for the game, it will write this template to enforce the method run game for the mini game, and the naming is consistent for all patterns. So it can be consistent when we call from the main.py. Same for the deep dive, it's run deep dive. And then this script will actually execute and create the main.py. So it will also write the main.py for this import, and it will iterate through each pattern in this patterns, so it will actually include the import for each one, so we don't have to write it manually. And then it will actually create a dictionary, which I will talk later. And then here, name, yes, for this part I will talk later, and the remaining are just the code logic for the main.py, which I will talk later. So in main.py, after we iterate through each pattern and import them, we have a dictionary. This is basically a dictionary of an integer to another dictionary, and in here we can actually see the name, the key value, the name, and the design pattern value, the game, which means the mini game, and its instance with the enforce method, run game, run deep dive. So it will be consistent. It will be consistent when we call from main.py. So for the first method, we have show menu. So at first it will create a table, and with a title of as this table you see here, and then it will start adding columns. So in here it will add 3 columns: pattern, number, pattern name, and description. And then patterns.items. So it will iterate through this patterns indexing. So when adding row, they will add each row, and for each separate commas, they are for in different free columns. So for this one, it will be added to the number rows, number columns, and pattern. They will get the key name. They will get the key name. So let's say the error is singleton. So the pattern will be singleton. And interactive minigame, they access the key name again to get that. And after iterating all 23 patterns, it will add the last one, 0, to exit the playground. And then in the console, we'll actually print the table, so it's visible to us. And then we have the method called select mode. So let's talk about the main method first. So at first, the console will print out this message for us to see, this green message, bold green, and then it will runs while true loop. And at first, it will run the show menu. So basically, it just shows the menu, and then it will try to get the user prompt from here. So if the user just press enter, the default will be 0, which is basically quit the program, as you can see. And for when we press R to get a randomized random design pattern, what it will do is basically choose. So at first we will take keys from the patterns and make it becomes a list. So the keys of the patterns are basically these number from 1 to 23, and we make it become a list. So So basically for this part, it's a list running from 1 to 23, and then it will choose randomly in 1 to 23. So Joyce will now become an integer. And then here it will access the pattern based on the integer. So let's say 1, we get singleton, and then we access the name, the key name. So we will get the singleton as string. So this will display randomly the selected pattern, singleton. Yep. And then if the choice is not random, then it will try turn the user choice to an integer. Because, right, let's say I say ABC, it will actually print an invalid message, and it will make me return to the menu. So here, accept sends me a message and continue to run back the loop again of show menu. But if the choice, if it's not in patterns, so basically, so here in this part, it will actually check if our choice is integer or not. And if choice is 0, then we'll quit the program with the yellow goodbye. Or if it's an integer, but it's not 0, but it's not in the patterns, so that will be in case of integer that is maybe higher or negative number. So for example, you enter 29, which is not which is not a valid number. We'll say invalid choice, please enter valid pattern number. So after the program get the choice as integer, so now the choice is actually an integer. We get the pattern again by plugging this choice in. We get the whole dictionary. And then they start and then we will access the key name of that pattern. So in this case, it will be singleton and pass as a parameter to the select mode. So let's say singleton got passed in as a string, and then it uses this pattern name to display you selected singleton. So let's say 1, you selected singleton, and it will show you if you wanna choose between playing mini games or the deep dive mode, or just go back to the menu. And here it will there will be another while true loop, which will integer prompt. So it will expect an integer as a choice, or if you just enter, then it will be default to 1, which is playing the mini game. So if the choice is integer and it's either 1, 0, 1, 2, 0 to back to the menu, 1 for the mini game, and 2 for the deep dive mode, we will return the choice as the integer, or else it will print invalid choice and it will run back the while true loop again. So after returning the choice as integer, it will be passed into this variable called mode. So we will start. So we will have the if and else if statement. So if the mode, which is an integer, and it's either 0 or 1 or 2, and if it's 1, we will access the key game in that pattern. So let's say we already have singleton, we enter the key game, so the value will be the game itself, the singleton game, with the method of running the mini game. And then with this double round brackets, it will become an actual function that will actually run it. So let's go into the singleton game. So the singleton game is this file, and when it's run the method called run game, it will run the game logic. Okay, so, and this applies the same to the deep dive mode. And if the choice is either not 1 or 2, but from earlier in the select mode, we only return a choice that is either 1, 0, 1, 2, and 1, 2 already have conditions, then if the mode is either not 1 or 2, then it's definitely 0, so it will return to the main menu. And I also create if name equals main condition running the main, so this will ensure that when you import it anywhere else, it won't run unexpectedly. Like if you intended to run this directly, you should put it like this, so for safe importing. The repo for this project is down in the description. So yeah.